Okay, so I guess I'll just kick things off. My name's Anjeanette Roberts, and I go by AJ, so AJ's fine. I am a PhD by training. I got my PhD decades ago from the University of Pennsylvania, where I did virology research, studying viruses, mostly how viruses infect, how they move from cell type to cell type, and what type of immune responses and pathologies or diseases are associated with human virus infections. That's what I did my grad school work on. That was a 5-year program. After that, I did 5 years of postdoctoral work at Yale. And there I started working on proof of concept for vaccine studies and for virus prophylaxis. So how can you prevent the virus from entering the cells? How can you prevent the virus spreading from cell to cell? How can you prevent transmission of viruses from living host to living host? How can you interrupt the disease process? How can you interrupt the pathology process? So I did that for 5 years at Yale. And then I did 2 years of Christian mission adventure work in Russia, where I was lecturing on HIV and AIDS. It was expanding in Russia at that time very rapidly. It was expanding in Russia more rapidly than in any other country or part of the world at that 2-year period that I was in Russia. And so I was just lecturing mostly to teachers and educators, but also to health professionals and students about how to prevent HIV and AIDS infection. And then when I came back from Russia, I spent 3 years at the National Institutes of Health. I worked in the National Institute of Allergy and Infectious Disease, also called NIAID, and you may have heard that acronym. It is the division of the NIH of which Tony Fauci is the head. Now, he's not the head of the NIH. The head of the NIH is Francis Collins, and you may recognize his name as the guy who started BioLogos. And so I was working at the NIH in a division that was under the oversight of Dr. Fauci. And I did that for 3 years. And I was studying the first time the coronavirus, Sars Coronavirus, had caused serious disease, illness, and death in human beings. That's not to say that coronaviruses had never infected us before. They had. There'd been a lot of coronaviruses that were associated with the common cold, but none that had been associated with severe disease. And 2 of those in particular have been around since before the 1950s. And you may not have even ever heard the names of those viruses. And if I told you the names of those coronaviruses today, you'd promptly forget them because very boring names with numbers and letters. So all of that to say that it was 2003, so the end of 2002 and the beginning of 2003, when the first SARS coronavirus caused a pandemic that was much smaller than this one. But because viruses are categorized based on their basic biology and not so much like where they came from, the source or the animal that they came from, but the way that the virus is structured physically and the way that the virus replicates, the way it makes more virus when it gets inside a cell. That's how viruses get classified. And so this virus is very similar to the virus that I studied at the NIH. It's so similar that it has almost the same name. It's called SARS-2. So it's the closest virus we knew of before this virus emerged. So that's sort of my background that's relevant to why I'm talking to you today. But when I left the NIH, I didn't leave virology. I didn't leave the study of viruses. I went into graduate education for 7 years. And then I left graduate education and went into work with Christian nonprofits at the interface of science and Christian faith. First with an organization at Yale for 15 months, and then with RTB for, I think I was there 5 years, a little over 5 years, counting the year that I was there as a visiting fellow. So since I left RTB, and I left RTB last June, so I've been gone a little over a year. Since last August, I am coming up on my 1-year anniversary. I have been an examiner for the US Patent and Trademark Office in the division of biological patents. And so patents that are put forward mostly by, well, some are by individuals, Some are by companies, some are by groups of academic researchers, and they're all related primarily to the biomedical field, but not to, I just want to be clear, not to drugs for the most part, and not to vaccines on the whole part, for the large part. So I can't speak today as a representative of the USPTO. That's just absolutely prohibited. I can't answer questions about the process of the patent office as my individual work pertains. I can offer general questions that would be easily answered if you like hopped on Google and tried to find the answers that way. But the work that I do at the PTO, I can't speak in any type of informal or formal capacity as a representative of the PTO. So I just have to make that clear up front. So let's see. So you guys probably, if you have questions about COVID, you may be more immersed in the literature than I am. The job that I have with the PTO is a very demanding job, and I work about 110 hours every 2-week period. And so I don't have a lot of time to do other things. So I have not had time to research the recent statistics, but I hopefully will be able to answer any questions that you might have. All I will say is that I'm concerned about where we are in the pandemic in the US in 2 respects. We have 2 of the best and to date, 2 of the safest vaccines that we have ever had for any disease anywhere in the world available to us today to help fight COVID. I said 2, not 3. The J&J vaccine is adequate, but the J&J vaccine is not as good as the COVID or Moderna vaccines. That's true whether you're talking about the amount of antibodies, the protective immune response that it elicits, or the versatility of the vaccine if you need something like a booster. So I can comment a little bit on J&J if people are interested. I can't comment much because I haven't spent as much time looking at that. I haven't ever been as excited about the J&J vaccine other than it does what it needs to do adequately to keep people from dying and to keep them out of the hospital. And so if you've only ever gotten the J&J vaccine, great. If you don't want to get a vaccine and you're like, okay, I'll get a vaccine, but I don't want one that's got 2 doses, great, get the J&J vaccine. But if you want the best vaccine you can get, I would say get the Pfizer vaccine or the Moderna vaccine. I lean towards Pfizer, I always have, and I have no reason to doubt my decision of the past. So some of it was personal bias, some of it was slightly scientifically biased, but the slight, not significantly scientifically biased. So where we are today, despite having 2 of the best vaccines ever made for any disease available to us pretty much free of charge and at will at this point in the US, is that we have just over probably, I think it's 54% of the US population, I can double check that statistic, that is fully vaccinated. But the thing that's more disturbing to me is that we have probably 40% of the US population that's not vaccinated. And that to me just doesn't make sense. I mean, I understand some people's hesitation, but these vaccines have been out there. They've been in use since last December, and there is relatively 0 risk associated with these vaccines. And the ability of these vaccines to protect is overwhelmingly positive, to the point where people like me are just amazed that these vaccines are working as well as they're working. And the second thing that I'll say, sort of in introduction to where we are today, that's got me worried and or slightly, maybe sometimes more than slightly upset, is that we are almost, we're at the second worst place we've ever been as far as daily incidence goes. We have over 110,000 new cases being reported almost on a day-to-day basis at this point. We haven't been this high since February of last year when this started, February when this started. So that's really, really, really disturbing. And what's even more disturbing to me is that the vast majority of the new infections are among the unvaccinated, the vast majority. The one statistic I looked up last week because somebody on Facebook asked me that I can throw out there as a comparison. The county of Dallas, Texas, I realize it's a very small nugget, but this is where they lived, and this was the basis of the question. The county of Dallas, Texas has about 81% fully vaccinated adult population. That's huge. Dallas still has significant infection levels. And of those significant infection levels, 84% of the people who are becoming infected with the Delta variant, the vast majority of them are the Delta variant infections, are unvaccinated people. So the reality is that the vaccine's working and it's protecting people who are vaccinated, and people who aren't vaccinated are very susceptible to the Delta variant. The troubling thing is that so are children. Children are being hospitalized on average. I think there are in some areas 200 new hospitalizations per day in Florida among children. And it's almost all the Delta variant. And the Delta variant is hitting populations that are very, very young, so infants. And that's really troubling because the vaccine's only emergency use for people age 12 and over. By the end of September, Pfizer hopes to be able to have the vaccine emergency use authorization to use in children ages 5 to 11. And the reason it's 5 to 11 is because that's school age. And whether or not the vaccine will ever go into children younger than the age of 5, I haven't heard anything about that. And I would imagine that that's sort of where the social pressure is the greatest. The concerns might be the greatest. We can talk about that if you want. Okay, all of that, and then this is the last thing I'm going to say, which is where do I go for my news? Where do I go for my statistics? And I mentioned this to Ross before we started recording, but I really trust the work of Johns Hopkins University, their public health center. And the reason being is that amongst scientists, especially amongst virologists, since before I started graduate school, Johns Hopkins has the best reputation for quality of work and the quality of academicians who go there. The doctors and the scientists who I know at every institution have extreme respect for Hopkins program. And Hopkins has been tracking the pandemic pretty much since week 1. They offer weekly, they used to offer daily updates, but I think they've slowed to weekly updates, and I don't think they've switched back to daily as we've been hitting the second wave of the Delta variant. But I go to Hopkins, they compile the data, they're very upfront about what amount of lag there may be in their data because of reporting. If they report numbers that they feel like are underreporting, because different organizations or different countries, because they're tracking the pandemic globally, not just in the US, but they always have a section that's US specific. So I trust Hopkins. It's not to say that there probably aren't politically motivated people who work at Hopkins, but science as a whole really is a watchdog community within the scientific community itself. That watchdoggedness may not always translate into the public arena. Like the public may not see scientists sort of like butting heads with scientists and questioning and drilling down. But within the scientific community, Hopkins' reputation as an institution and the type of science that they produce is really among the top tier science research institutions. So anyway, I think I've been talking long enough. So what's up, Ross? Who wants to ask what?
Hi, AJ.
Hi.
Ross got kicked off.
Oh, Ross. Okay, who's going to be my Ross? Who's
He
going to be
lost
Ross's
his signal.
wingman?
I will ask
My
the
wingman.
questions. I will ask the questions. So,
all right. Thank you. Thank you, James.
Yeah. Sure. Mark Durham asks, Mark Durham in Southern California here, he asks, please describe viral taxonomy and how the COVID virus fits.
Oh, gosh. Okay. Yeah. Yawn. Sorry. Virus taxonomy. So, yeah. So the way that the way viruses get classified or named, and that's what the taxonomy is all about, is based on really The principal thing it's based on is the nature of the genetic material inside the viral structural proteins. Okay, so without getting too boring about viruses, because I could talk about virus taxonomy and structure and replication for days, not hours, for days. If you see, you've all probably seen a cartoon picture of COVID, maybe even an electron micrograph of COVID. And what it probably looked like if it was an electron micrograph was sort of a gray and white fuzzy ball with spikes coming off of it. So it used to be that viruses were classified morphologically or by disease, but that changed when we were able to rapidly isolate their nucleic acid. We're made of DNA. Viruses are made of DNA or RNA. And it just so happens that coronaviruses, so if it's a coronavirus, whether it causes the cold or whether it causes a pandemic, they all share basic structure at the genomic level. And what that structure is they are single-stranded. That means there's only one string of bases attached to each other. DNA is double-stranded. Our chromosomes are double-stranded DNA. The coronaviruses are all single-stranded. They're all RNA. And if you were to take that RNA and introduce just the RNA, not the virus, just the RNA from the virus into a cell, that RNA would be able to make proteins. And so that tells you it's a certain type of RNA, because there are two different types of RNA. One can make proteins, one can't. The one that can't has to go through an intermediate. So the ones that, like HIV is kind of complex, but it's kind of a good example. HIV can't really make proteins on its own. It has to first get reverse transcribed into DNA. And then from the DNA, it has to go into the positive sense RNA, which can then make proteins. Well, coronaviruses have the right kind of RNA. They don't have to be transcribed into DNA and then made into RNA. Their RNA functions to be able to make proteins immediately. So the first thing you ask, if you're going to try and classify taxonomically, what type of virus do you have? You need to know what is the genetic makeup of the virus. And so the RNA of coronaviruses is very, very, very long, speaking about the sizes of viruses. It's 30,000, on average, 30,000 bases long. And so that's a pretty long genome. I studied a virus in grad school that was only 7,000. So 1/5, between 1/4 and 1/5 that size. That means that the coronavirus is also, for an RNA virus, the coronavirus is fairly complex. And as far as RNA viruses go, that is the largest RNA viral genome that's out there that infects human, our coronaviruses. So I think that's enough about taxonomy. There are a couple of other things that go into the taxonomical classification, but that's the most important one. Like I said, yawn.
No,
There's way too much science, but go
very
ahead.
interesting.
Next question.
Well, this is a very science-based sort of class here. So
I'll make one other comparison. The flu virus is much smaller than it's the same type of RNA in the sense that if you take, is that true? No, it's not true. Actually, flu is a negative stranded RNA. So if you take flu RNA and put it into a cell, it can't make proteins. It has to first be transcribed back, not necessarily into DNA, but it has to be made into the right kind of RNA for it to be able to function and make proteins. And the other difference is that flu has pieces. Like we have chromosomes, we have multiple chromosomes. Flu has multiple pieces of RNA. It's something called a segmented genome. And the coronaviruses don't. Coronaviruses have one piece and it's really super long. Okay.
Thank you. I have a question myself.
Yeah, go for it, Jamie.
See if I can get this out right. So
that's okay.
You were talking about kids having actual danger.
Yes.
Of kids actually. Sorry, I'm juggling Ross here too, trying to get him back up. Okay. Kids actually getting coronavirus and being a danger to them. First, is there a lot of deaths in the children? Or a lot of
no. As far as I know, there's not a high case fatality rate in the kids, but they are being hospitalized. And I'm not saying that it's at extreme rates, but and I don't want to even begin to speculate. The point is that it is spreading. It's spreading among kids, and they're getting sick enough that many of them, I won't say even the majority, because that's probably not true, some percentage of them are having to be hospitalized. So it's either enough infections or a high enough number that are getting sick enough that the result is that in some places in Florida and elsewhere, there's up to 200 admittances per day for kids. So that's high. That's high.
Yeah. Are they having the long-term effects as well? Do you know?
Don't know yet. Don't know yet. Delta's been spreading like crazy since I think I can't remember when it came, like when they pinpointed, okay, it's made the jump from Europe over here, but it's been spreading pretty crazily for the last at least month and a half, since the beginning of July, probably earlier than that. But so we just don't have data on whether or not it's going to have long-term effects.
So that wasn't what my question is. That the news outlets and YouTube are saying that kids are almost saying like they're not in danger at all. It's almost coming across that way. How do we change that messaging? I mean, how do you think we can change it? Do you have any ideas on that?
I just think we need to be as responsible as we can as individuals to say, it's interesting. I lead a spiritual formation group, kind of a bunch of women who are out there, either moms or professionals that are just wanting to go deeper into God and do it with each other, sort of encouraging one another in our faith. And yesterday we met and I led a little devotional, and the devotional was based on two sort of liturgical prayer reflections. And one was about consuming media, and the other one was about sort of like a prayer before you serve other people. And so I combined those two things into how do we engage on social media, because we are both consumers of social media to a certain extent, but we're also participants in the social media that's being consumed. And so I think the most important thing I could say is we don't want to get out there and just start whacking each other over the heads with opinions or statistics. We really want to take the heart of Jesus into social media. I'm here to serve. I'm here to try and help you understand the situation best I can. I'm going to be as truthful with you as I can, but first and foremost, I'm here to love you and to serve you, because you're more important to me than me winning a debate or anything like that. So yeah, be careful not to repeat things that you're not sure of. Be careful not to repeat things no matter how much your heart resonates with what you've heard. Be careful not to repeat it if you haven't had the opportunity to say, is this trustworthy? And you might say, well, how on earth can I tell if it's trustworthy? Well, I heard this statistic and I found it shocking, and I didn't have time to fact check it. But I also, my own bias was, I bet that's true. And so I'm going to repeat it, but I'm going to repeat it with all those disclaimers that I just led with. What the statistic was that I heard is that, and I know we're not really talking about anti-vaxxers and that sort of thing, and I don't necessarily want to take us down that road, but the issue was that the element of the population, specifically in America and Europe, that does not trust vaccines as a whole, these people are sometimes referred to as anti-vaxxers, that the vast majority of anti-vax negative postings on social media can be traced back to 12 individuals. Not 12 sources of media, not 12 sources of research institutions, not 12 sources of scientific publications, but 12 individuals responsible for 95% of the anti-vax and misinformation about vaccines on social media. Stunning if it's true. So all that to say, if you're going to repeat something, if it's true, there are probably numerous different media outlets, news sources, individuals whom you might trust that are going to be, you're going to be able to point to back yourself up. Not necessarily to one YouTube video, not necessarily to 2 social media sites. So you got to do your homework. And if you don't, then you're possibly contributing to the misinformation that is confusing the rest of the vast majority of our fellow Americans. So just be careful and remember to keep a servant's heart. You know, it's about loving God, it's about loving one another, and it's about trying to seek the truth together for the good of all.
Thank you. Great answer. Thanks. Kurt McCorkle asks, I got a paragraph here for you.
Okay.
It looks like several questions, so I might have to split it up.
May have to take one at a time because I probably won't remember them if you give them to me all at once.
Right. And I'm going to have to click off here and help Ross try to get back on here. So, yeah, his computer tanked for a second, so we'll try to get him back. Kurt asks, how do virus pandemics usually progress and eventually end like the 1918 Spanish flu? And how might the current pandemic's path be altered by the widespread lockdowns and new vaccines? In particular, some have argued that the vaccine focused on one spike protein and not completely effective, leaky, applied as it has been, can actually promote the spread and more lethal mutations of the virus. Do you agree? How might that work? Do you want to go back over those one?
Just bring me back to the first one, and then I think I can remember the second one. But yeah.
Okay, the first one is how do virus pandemics progress and eventually end?
Okay. Yeah. So, Kurt, great questions. So you're going to hate my answer, all of my answers, because the vast majority of my answer to the second part of your question is going to be, well, we don't really know, but we'll get there in just a second. First of all, pandemics, let's take a look at the 1918 flu pandemic for some specifics, but keep in mind that the specifics of the flu pandemic of 1918, you're talking about a different virus. You're talking about a different virus structure. You're talking about different virus biology inside and outside of the human host. And you're talking about different aspects of how robust the virus is in the environment, okay? So everybody should realize that this is true, that influenza, is a seasonal infection. We have a flu season. There has been speculation since the beginning of this pandemic as to whether or not COVID or SARS-2 would be seasonal. There is little indication, and it's really hard to sort through it at this point in time, but there is little indication that it is actually seasonal. That's not to say there's not any indication that it might be seasonal, but the reality is that Florida, and I hate to pick on Florida, but they're just going to be a really good case study at the present time. Florida right now, in the heat of summer, is in the worst part of the pandemic that Florida has faced. So if you take that one bit of sort of observational data, it would lead you to say, well, we hope this isn't seasonal, because if this is seasonal and it's the heat of summer and Florida is having the worst pandemic it's ever faced, then hold on to your hats, because fall's coming in a couple of months and it's going to get worse, because all respiratory viruses, regardless of whether they're seasonal or not, will have an uptick in the colder months, because the viruses can withstand colder weather longer than they can withstand warmer weather. But what we know from the first SARS virus, way back when I was studying it at the NIH, and this one, is that it's pretty robust as far as its ability to withstand heat. And so we wouldn't expect the same type of seasonality. And in fact, we're not seeing the same type of seasonality. So how long is this? How long does a pandemic last? How does it get started? It gets started because we encounter a virus that we've never seen before as a human population. And so in 1918, of course, flu had been around before then. But what actually happened in 1917, so the year before we refer to the pandemic, is that the flu viruses were co-infecting different animals, such as birds. Flu can also infect pigs. It can infect humans. It can infect a wide variety of animals. And it depends on the specific type or strain of flu as to which animals it might infect best. But when one type of flu, infects an animal or a cell, what can happen is that same cell can be infected with a different strain of flu. And so you can actually have two strains of flu infecting one cell. And when that happens, because there are pieces, like we have chromosomes in our genome, and I told you flu has pieces, it has segments, and those pieces from the two different flu strains can be shuffled. And when they're shuffled and you package a new virus that's coming out of that infected cell, it can have all different combinations of those segments. And when that happens, the virus can become something that we haven't ever really seen before, in the sense that it's a unique shuffling of the viral segments. And so just imagine like you've shuffled a red deck and a blue deck. And now instead of having a virus that's all red pieces or all blue pieces, you now have a virus that's blue and red. And the cell or the population has never seen a virus that's had that particular combination of blue and red. And so that's what kicked off the influenza pandemic that had a herald wave, a wave that was sort of not as high as the pandemic wave, but a herald wave in the late season of 1917. And so it basically said, oh, look, here's a virus we haven't really seen before as a population. People were getting sick, seasonality ended, and then before the next season was due to start, we had the pandemic wave. And so we don't really know what happened in the 1918 flu pandemic that made it act non-seasonal for a very short period of time. But the pandemic wave, there was actually two waves to the pandemic. And so you might look at what we're facing now in this COVID pandemic and say, oh, well, we had wave one that sort of calmed down to a low point of around May or June of this year. But now we're hitting a second wave of the pandemic in the US because of the Delta variant. And so we don't really know, we can't tell you what was happening genetically back in the 1918 pandemic because we don't have any samples from sort of that first wave. We only have it from late waves. And that one's been sequenced, we've analyzed it, and we're still kind of left scratching our heads. We don't really know what happened to make that particular influenza strain more easily spread, more able to cause disease, illness, and death. And so there are certain things that we can't answer as scientists, right? We can only make observations. And so the second part of your question, Kurt, and I'm sorry my answers are so long, but these are really complex topics, is that we don't know how this virus is going to continue to change. So to the first point, the vaccines actually did an excellent job of hitting not just the variant that they were developed to hit, but to be broad enough that there have been multiple variants identified. And it just so happens that the Delta variant is the one that seems to be the most contagious, the most easily spread, right? And so the Delta variant is spreading rapidly, but it's spreading rapidly primarily through the unvaccinated population. So it's not that the vaccine's not working. In fact, the vaccine's working very good. It's keeping you well protected against the Delta variant to the point where there are very few breakthrough cases in vaccinated people that will actually send them to the hospital. And there are even fewer amongst that population that would be lead to a fatality. So the original vaccines developed by Pfizer and Moderna are doing an extremely great job, not just in the variant that they were developed against, but every other variant, including the most easily transmissible variant, Delta. And so right now we have, scientifically speaking, guys, we should be marveling at how great these vaccines are. I mean, these vaccines are doing far beyond what we thought they would do. They're being far more effective than we thought they would be. And they're being far more effective against variants they were not developed to target, and yet they're still offering protection. And so that is just phenomenal. And what we're also learning is that in some instances, a third dose actually is boosting the immune system in people who didn't get a good response to the first 2 doses. And so a third dose of the same vaccine, I'm not even talking about going out and making one that's specific for Delta variant or some other variant, the same vaccine, a third dose, is giving even more protection amongst people who didn't get great protection after 2 doses. And so you might say, hey, well, wait, why does some people have to get 3 doses and some people have to get 2 doses? Well, do you ever get the flu? Do you ever know anybody who gets the flu? Is your flu sort of the same as somebody else's flu? I don't think I've ever had the flu in my entire life. And if I have, maybe only once. And if I had it, I got really, really sick. But for the most part, and I haven't been vaccinated against the flu in the vast majority of the decades of my life, although for the past decade and a half, I have been vaccinated every year. Ever since I worked at the NIH, I've been vaccinated for the flu. So every year. And so it's like, we are physiologically different. Ross and I could be exposed to the exact same virus, and I may get dog sick, and Ross may have a headache and be just fine. And Jamie might get the same virus and not even feel a thing. And it's like, was the virus different? No, but Ross's physiology is different. Ross's underlying medical conditions and health are different than me. And so the virus is going to behave differently in me than it's going to behave in Ross. It's just the way it is. The vaccines are behaving very similarly in the vast majority of us, and they're doing what they need to do because they're tiny bits of pieces of the virus, right? And they're tiny bits of pieces of the virus that are introduced into us in a way that our immune system, our cells can take it up, our cells can present the proteins to our immune system, and our immune system can respond to those proteins and give us a level of protection. What level of protection? Well, the level of protection isn't dependent upon the vaccine. The level of protection is dependent upon our physiology, the same physiology that would be reacting if we were infected by a virus, right? So if I get vaccinated and I don't have very good antibody, if I don't have very good protection elicited by the vaccine, I get a booster or I get a second dose. All of us are getting a second dose because we all need at least one boost. If I get a third dose, is it still boosting? Yes, it's probably still boosting. Depends on how strong my reaction was to the second dose. If it was really strong to the second dose, third dose may not be effective because my immune system is already like, yeah, bring it on, right? It's like, it's already as good as it's going to get. But if it's not as good as it's going to get, then a third shot can help make it better. But the point is that if I've been vaccinated twice and I didn't get a hooyah response out and I get infected by the virus, then maybe the virus can get in, but my immune system is still going to be sort of ready for it. It's not going to stay as long. It's not going to replicate as much, and I'm not going to get as sick. It's a good thing all the way around. It's going to keep me well-er than I would have been. It's going to keep me from being a little virus factory for multiple days, walking around spreading virus everywhere I go. I may be a virus factory for a day or two, but I won't be a virus factory for 2 weeks, right? So all of this to say, yes, there may be breakthrough cases in fully vaccinated people, but even those breakthrough cases, those people won't be getting as sick as they would have gotten if they had seen the virus before they were vaccinated, right? Because if their immune system didn't respond well to the vaccines and they're already getting sick in a fully vaccinated state, then if they saw that virus before they were vaccinated, they would be toast, basically. I wouldn't say that they'd be dead, but they'd probably be very, very sick, and they'd probably be in the hospital. So you can point to a breakthrough case and say, oh, look, the vaccine's really not that great. That is such an unfair false judgment of the situation. that person was vaccinated. Thank God. Because if they hadn't been vaccinated and they just saw the virus, they'd probably be in the hospital, maybe worse. So.
AJ, I got a question. Are any of the concerns that are out there about the virus, in your opinion, reasonable? Specifically, the one that says we just don't know what the long-term results of it are going to be?
Of the virus?
Of the vaccine, I'm sorry.
Yeah, because you said the virus.
Yeah.
So yeah, of the vaccine, no. Those types of speculations, I never want to sound like I'm 100% sure about anything. Okay, because it's almost impossible to ever be 100% sure about anything other than I know I'm saved and I know God's real and I know Jesus is coming back. I can be sure of all of those things. But there is no reason that I can think of or imagine, Ross, that these vaccines are going to have any type of deleterious long-term effect, period, in anybody for any reason. And this is why. These vaccines are specifically designed to go into a cell. Once it's in a cell, the RNA provides the material that needs to be provided to make a protein, and then the RNA is degraded. The RNA isn't even there the day after you got the vaccine, right? The RNA is gone by the time you've made the proteins and you're starting to develop antibodies to the protein, because the RNA doesn't go in and make more RNA. The RNA doesn't even go into the nucleus of the cell. The nucleus of the cell is where your DNA is. That's where your chromosomes are, okay? So when your cell is being a healthy cell and it's doing everything it needs to do, in the nucleus, the DNA is being transcribed by proteins in the nucleus into RNA. And then there are other proteins that take the RNA from the nucleus and transport it into the cytoplasm, right? And so the DNA stays in the nucleus, the RNA gets transported out into the cytoplasm. And if you don't know, a cell has two basic compartments. It has the cell body, which is the cytoplasm, and inside the cytoplasm, there is a smaller compartment called the nucleus. The nucleus has its own membrane. It has pores in the membrane, but things can't just go in and out of the pores. They have to be transported. And there are signals on RNAs and on proteins that allow them to be transported in and out, mostly out of the nucleus, but some proteins get transported into the nucleus, but they're chaperone proteins. It doesn't matter, too much biology. But the point is that the RNA from the vaccine goes into the cytoplasm of your cell. RNA hangs out in the cytoplasm. It hooks up with the ribosomal machinery that translates RNA into proteins, and the proteins get made in your cytoplasm. And so you have a lipid membrane that fuses with the cell membrane. The RNA of the vaccine gets released into the cytoplasm. The RNA of the vaccine hooks up with the ribosomal machinery and makes proteins, and the RNA gets degraded, gone, okay? All that you're left with for the next several days are these proteins, and these proteins are getting presented on the outside of the cell surface, and your immune cells are coming around and saying, hey, look at that protein. Hey, everybody, come here. This protein doesn't belong. Let's make an immune response to it, right? And so that happens, you get some immunity. You know, you probably get 30%, 40% effective immunity after a single dose. Second time, that lipid body comes in, does the same thing, fuses with the cell membrane, releases the RNA. The RNA hooks up with the ribosomal machinery, makes some protein. The RNA gets degraded, vaccine element's gone, and that protein is getting presented on the outside of the cell. The immune system sees it, and they're like, hey, we just saw this. Everybody get over here faster, right? And so you have a much stronger reaction to the second dose, much faster reaction to the second dose, and the game gets played out so that if you ever see the virus, the response is so quick that the virus never gets a foothold. That's when you have protective immunity. That's when the vaccine's working pretty much 100% within that individual. So there's no component of the vaccine, Ross, that could ever remain in your cell for a prolonged period of time. It's impossible for me to imagine a scenario where these vaccines would have a long-term potential for a deleterious effect. There's no scientific basis for how that could happen.
I want to remind everybody to ask your questions in Q&A, but I think it was Marge Harmon had a really good question in the chat, and I'm just going to bump it up because it was a good question. And that is, AJ, why then are there so many medical professionals in the news that are talking about not getting the vaccine, in your opinion?
I haven't seen so many medical professionals in the news talking about not getting the vaccine. So I would question your news source if that's all you're seeing, or if that's primarily what you're seeing. Yeah, so there are a few people who have had blood clotting disorders that are contraindicated for the Pfizer and the Moderna vaccines. So what does that mean? It means if you know you have a blood clotting disorder, if you know that you don't, like if you are prone to bleed a lot longer than most people when you get cut, then you probably have a blood clotting disorder. If you're hemophiliac, you have a blood clotting disorder. So these people at a very low percentage, primarily women, not really sure why that's true, primarily women in the middle-aged years who have that disposition have been showing adverse reactions to a higher percent than other categories of people who are being vaccinated to have severe adverse reactions to the vaccines. But that's the only contraindication to the vaccines that I've seen that is well established and significant enough that it's a concern and should be a concern. So I have a couple of friends who are women who are in their middle ages who have blood clotting disorders, and I've told them to talk to their physicians, but I've said, you know, based on what your physician tells you, like if he's concerned or she's concerned, then sort of take their lead. If they think, no, you're at greater risk because you have these other underlying medical conditions that will put you at greater risk if you actually get infected with the virus, then my suggestion would be vaccinated, but be vaccinated under medical supervision. Like, don't just go to a vaccine clinic. Don't just show up in the line at Walmart or wherever and get your vaccine there. Make an appointment at a doctor's office. Go to a hospital clinic where they will allow you to sort of stay there for several hours and get your vaccine under medical supervision. So.
Okay. Jamie, I don't know where you left off with the questions. My computer abandoned me for a while. Do you want me to just pick up with the question, Susan, or did you do that one already?
Either way, Jamie, Ross, you guys can take turns. I don't really care. Whatever you guys want to do.
It's fine. Go ahead. Go ahead, Ross.
Well, Doug's got a good question. I'm going to ask the second half of his question first. Does sunlight kill the virus? If so, how quickly? In other words, should we be outside a lot?
So outside is way safer than the inside, but it has very little to do with the sunlight killing the virus. It has to do with virus dissipation, and you're not in confined spaces. And so it's always going to be easier for a virus to dissipate further away outside than it is inside. You're not going to get like weird room circulation of air outside like you might get inside. So the surprising thing is that when you talk, whether you realize it or not, you're actually projecting small particles, small damp particles, and those particles have a certain like capacity to travel, and they can stay airborne for quite a long time. And so if you're inside, it's a very risky environment if you're not masked and or socially distanced. So why socially distanced? Well, the social distance is because we typically think of virus, not virus, but like those small particles when we speak, that they'll go out and they'll fall off because they do have some mass to them. They will by gravity fall away. But what the studies have shown is that, sort of surprisingly, is that the particles that can actually bear SARS are staying aloft further. And so aloft further, that's if you don't have a mask on. But the social distancing was always primarily based on those sort of models of, when I speak, I spew. And some of what I spew you can't see, but it sort of falls off after about 6 feet. You know, really falls off probably closer to 12 feet, almost completely. But 6 feet is sort of like, it's a good distance to try and keep. And then if you put on top of that, oh, by the way, put a mask on, then yeah, 6 feet is definitely far enough if you have a mask on, because the mask is basically, again, the mask, I say again, hopefully because you've heard this before, and I'm not the first person to tell you this, the mask is not primarily protecting you from other people. The mask is keeping whatever you're spewing away from traveling towards other people, because up to 50% of infections, you don't know you have it. They're asymptomatic, right? And so you can feel fine. You can be out and about and think, oh, well, I'm fine. I don't need to have a mask on, right? And the truth is that no, you could be one of those little virus factories that's running around for 2 weeks spewing virus on top of everybody you talk to. So the mask is to keep your nasty little particles closer to your wonderful, beautiful little face, and to keep them away from other people. And so I'm only safe if you're wearing a mask. You're only safe if I'm wearing a mask. So me wearing a mask is all about me loving the people around me, right? It's not about I'm afraid of the people around me. Will the mask protect you if somebody else doesn't have a mask on and they're a little virus factory spewing viruses? Yes, it will give you some level of protection. I can't give you a percentage. Will it be completely protective? No. If it was an N95, would it be completely protective? Yes, if you were wearing it properly. But the vast majority of the masks that we're all running around in are not N95s. And so we're not really protecting ourselves from other people. We're protecting other people from us inadvertently spreading the virus to them. So did that answer your question, Ross? Or the question, Ross?
I think so.
Okay.
All right, let's go to a question by Susan Lambeau. Why is it that vaccines for coronavirus have never succeeded before?
We've never had a vaccine for coronavirus before. We've never tried, we've never developed one and tested it in humans before, except for the first time SARS came around in 2003. We developed all kinds of vaccines at that point, and they were tested in animal models, and they were all extremely effective in the animal models they were tested in. And they never went into clinical trials because the first SARS pandemic ended quicker than this one did.
Thank you.
Much quicker.
Next question from Dennis. Why hasn't the FDA approved the vaccines yet?
Because the FDA is notoriously cautious. So frustratingly so for many scientists. And it is a very bureaucratic organization. To our good, perhaps, to many people's, there are a lot of people that are very frustrated with the FDA, not in regard to COVID, but in regard to orphan drugs and in regard to other vaccines and how long it takes for licensing to take place. But the reality is that the FDA has decades and decades of experiences of saying, we don't care how loud you yell. We are being overly cautious because once we license something, we're basically putting our reputation and our trust level on the line as the FDA. And they don't want to do that because in the past they've been burned. And when they get burned, it's usually for unforeseeable reasons. So for instance, when polio vaccinations were taking place, there was something called the Cutter incident. And it was a polio vaccine that the manufacturing of the vaccine by the company called Cutter. And you might realize, hey, there's no biopharmaceutical company called Cutter anymore. Well, that's because this was the end of Cutter. But Cutter sort of changed the inactivation of the polio virus, because polio virus is one of two types. It's either an oral, live, weakened virus, or it was an injectable killed virus. And so Qatar was producing the injectable killed virus. They changed the procedure for inactivating the virus, and they released a very large batch of polio vaccine that was not completely inactivated. And so people were being injected with polio vaccine, and actually what they were getting was an incomplete killed virus, and people were developing polio. And so freaked everybody out. The FDA was like, pulled the licensure, and Qatar doesn't exist anymore. So that's one time FDA got burned. Second time FDA got burned, an RSV vaccine. You may be hearing about RSV if you're paying really close attention to the news right now and hadn't heard of it before, because RSV stands for respiratory syncytial virus. It's a virus that normally causes really bad respiratory diseases in infants. And so if you have an infant who is hospitalized with a respiratory disease, it's almost certainly either RSV or parainfluenza. And RSV kills infants every year. And so it's something that's been, the medical community, the scientific community has been trying to develop ways to prevent RSV infection in infants for decades. And they've also been trying to develop vaccines. And so there have been a vaccine for RSV, and there's been a vaccine for another infantile disease that causes diarrhea caused by a virus called reovirus. And both of those vaccines, when they initially were tested in small groups of infants or people, they looked relatively safe. But when you got into a larger population, what you actually found were a few infants who would get worse disease if they had had the vaccine and then encountered the virus. And again, it wasn't the vast majority of those that had been vaccinated, but there were underlying conditions that had gone undetected. And as far as I know, I don't know that we even know what those conditions are yet today, but it would predispose that individual infant, right, who's going to have a different physiology than the other infants that are being vaccinated. But that one type of underlying physiology, if they were vaccinated and then they got the virus, it would cause a really severe reaction. And so because of that, because it was only a small fraction of the vast majority of people that were, or infants that were being vaccinated, but it was such an adverse outcome, the FDA pulled licensure on both of those vaccines. Mm-hmm. And so the FDA doesn't want to get in a situation with a relatively new type of vaccine, right? So the Pfizer vaccine and the Moderna vaccine, the platforms, the way that the vaccines are, the structure of the vaccine are new vaccine structures, right? We haven't had these lipid nanoparticles that fuse at the cell surface, that release RNA, that degrade, that go away, the protein's there, the protein, we haven't had that type of delivery system in the human population, widespread before these two. And we didn't know how they were going to work. And so we don't have decades. We can't go back and say, oh, well, look, we've had the flu virus around, we've had the flu vaccine around forever. Yeah, these vaccines are totally different than those types of vaccines. And so there was an overabundance of caution on the part of the FDA because of the underlying type of vaccine. And so if the FDA licenses the Pfizer vaccine within the next 2 months, and I think they will, that will be, again, I mean, the public won't realize this, but that will be like a speeding train for the FDA, right? That you will never see the FDA license something so quickly as they will these COVID vaccines if they license them within the next 2 months. But at the same time, why haven't they already done it? Well, because the FDA is being overly abundantly cautious. These vaccines have been in billions. I think the statistic is that we have close to 1.4 billion doses of vaccines. So maybe not Pfizer and Moderna are billions yet, but they're certainly in the hundreds of millions. And the reality is, if you're going to have an adverse reaction to the vaccine, that will certainly show up probably within the first 3 days. Almost 100% certainly it will show up within the first 6 weeks. And so the fact that we are way past the first 6 weeks with these vaccines, and that we're in hundreds of millions of people, and certainly billions of doses at this point, then yeah, I just think the FDA they're overly cautious. They don't want to get burned, and yet they're still working at breakneck speed if they license this within the next 2 months. So.
Thank you, AJ. Kurt McCorkle asks, given your positive views of the vaccine, how do you respond to studies that show that vaccine effectiveness in July dropped to 42%? That was the Pfizer.
Yeah, I don't know. I'm not familiar with that study, and I don't know what population they were studying. So if they were studying those that were vaccinated back in December, or if they were studying effectiveness against the strain that's the prevalent strain now, which is the Delta variant, that may in fact be what they were studying, because those numbers would seem to fit my suspicion in that category. So the point there would be, who asked this question?
Sorry, I already.
Well, I just wanted to use the person's name.
Kurt McCorkle.
Kurt. Okay, so Kurt. So what I suspect that study is, and I could be wrong, but what I suspect that study is that the vaccine effectiveness against the predominant strain that's circulating. The predominant strain that's circulating is the Delta variant. So then you have to ask, well, what do you mean by vaccine effectiveness? Do you mean, is it able to prevent the virus from getting in and setting up an infection? And if the answer is only 42% of the time is it effective in doing that, then okay, that's not a big deal in this respect. The next question you have to ask is, in the 58% of people that are getting infected, what percentage are showing signs of significant illness? They don't feel good. They can't go to work for a few days. How long are they testing positive after their infection? Is it 3 days and they're no longer testing positive, so the virus is basically gone out of their system for most considerations after 3 days? So yeah, they were infected, but they were infected for a very short amount of time. Yeah, they were infected. They tested positive on the first test, but not on the second test. They were infected, but didn't really feel sick. What percentage of them ended up feeling really sick to the point of like not being able to go to work? What percent ended up hospitalized? What percent ended up dead? Those are really all of the things that you need to know if you're going to try and address like the effectiveness of the vaccine. So to just say to me, although I haven't seen the study, but just to say to anybody, oh, the vaccine's only 42% effective in July. Well, 42% effective by what standard and to what variant and under what conditions? Mm-hmm. Because it could still be 90% effective of keeping people out of the hospital. It could still be 99% effective of keeping people from dying. If it's only 42% effective in preventing a detectable infection, okay. So maybe now and I don't want to slam J&J unfairly, but maybe now it's just a little worse than the J&J vaccine, right? But it's still doing everything 99% effective, 95% effective, whatever the effectiveness was against the other variants. It's just this variant, it's only 42% effective from preventing infection, but still 90% effective of keeping you out of the hospital.
Thank you. Kurt McCorkle asks, why are there large new waves of the virus in countries with greater than 90% vaccination rates, such as Israel, Iceland, and Gibraltar?
Because there's probably only 42% effectiveness of stopping secondary infections against this variant. So people are testing positive, but they're not getting sick, right? So, and because the 10% is probably very susceptible, and so the numbers of people being infected in that remaining 10% are getting sick. They're testing positive because this is much more contagious.
Good. All right, next question. I haven't read it through yet, so I'm going to try to read it first time and see if I mess it up. This is from Bob and Sharon. It says, Dr. Peter McCullough, professor and researcher at Texas A&M, is very concerned for all of the vaccine injuries occurring. There have been over 12,000 deaths connected with the vaccine as seen on open VAERS, VAERS.com. Pericarditis and myocarditis, blood clotting, Bell's palsy, and death are emerging. He uses Ivermectin, HCQ plus zinc, antibody therapies that are effective when treating the disease early. According to Dr. McCullough, if you are under 50 and no comorbidities, you have less than 1% chance of hospitalization or death. Then why would anyone be vaccinated with a 94% effectiveness versus your God-given immune system that is 99% effective? SARS-CoV-2 cannot be transmitted in asymptomatic people. How's that for a question?
Yeah, I'm not sure how much of that was Bob and Sharon or Bob and Sharon quoting the doctor from University of Houston, Texas. Which one? University
Texas
of Texas
A&M.
Texas A&M. Yeah, I'm not familiar with that particular individual's work or his data, but yeah, I don't know where to begin to address this other than to say I would be highly suspicious of the vast majority of the data presented in that question without taking a look at the specifics. For this reason, if there were 12,000 deaths associated with the vaccine in any population, I would suspect that I would be hearing that from individuals, not just one individual at Texas A&M, but numerous individuals, including medical researchers at UCLA, Baylor, Hopkins, Penn. Yeah, I just have to say I'm highly skeptical as to the doctor's data and findings. I'm skeptical. So that's the only response I can give.
Okay.
And it comes back to what do we repeat on social media, right? One individual is making these assertions. If those assertions are true, there will be data from other reliable sources that will be backing up those assertions. Okay. Because there is not a mass conspiracy in the scientific and medical community to squelch data.
Well, let me ask you this from me then. What would you say are the one or two or three most reliable sources that people can go to that aren't so technical that we can't understand it, that are the most trustworthy sources for information about the status of the virus?
Well, I come back to the Hopkins organization for the reasons that I stated at the beginning. So if people didn't hear that, they can replay the tape. Certainly Hopkins isn't the only institution that I trust, but they are the most reliable, and they put out daily and or weekly briefs, and you can look at the historical reports there. I have in the past pointed people to the CDC, and it's not that I'm hesitant. Well, I am hesitant to point them to the CDC only for this reason at this point in time. It's because the CDC's reputation in this particular pandemic, not necessarily in the public, but in the scientific community, has been damaged. And one of the things that may result in a major shift in public policy in America when we kind of get to the point where we're resolving issues and the pandemic's finally, hopefully, behind us, and I don't know when that'll be, but I think one of the public policy changes that might be coming down the road is that whoever the president is in the future may not have the luxury of appointing the head of the NIH or the CDC. And I actually think that we as Americans might really want to consider that type of public policy change, because politics should not be dictating one way or the other measures that are really about public health and public safety. And so I would say that if you just want to know like basic nuts and bolts about how things get produced or tested, or what types of tests are available, or what types of vaccines are available, or what types of vaccines are recommended for travel to particular types of the world, then yes, I would still point people to the CDC. But if you want information about how is the virus behaving, how is it changing, what's the safest way to protect yourself, I would point to sources at Hopkins. I don't know. I've never had somebody who wasn't sort of like a biology head listen to this podcast, but there's a podcast called This Week in Virology. And it's a bunch of virologists that sit around and talk about what's going on around the world from a virologist perspective. And this podcast has been out there for a very long time. It's run by a professor at Columbia in New York City, a guy named Vince Racaniello, who I actually kind of sort of know. I mean, I met him on one occasion. I actually interviewed at Columbia for graduate school, and I interviewed with Vince. So I doubt that he would remember me, because he's probably interviewed thousands of graduate students. But anyway, so he always invites usually 3 or 4 other virologists, and they'll pick a different topic each week, and they will talk about viruses. And so they've had numerous podcasts, as you can imagine, over the last year and a half that have dealt with the virus, COVID, where did it come from? What's the best hope for, all kinds of things like that. So that's pretty non-mainstream. It might be consumable by somebody who doesn't have a strong biology background. I'm just not really sure. Yeah, and I just have to say, I saw something come past on the chat, and I haven't been reading the chat. So if I haven't mentioned you, it's because I haven't seen it. But I just saw something come past, and I didn't focus on who said it. But there was the comment, like, I don't seem to be in tune with anything other than what mainstream doctors are saying. And I just have to say, folks, in response to that there's a reason they're mainstream doctors. I mean, there is a reason why the scientific community, not the medical community, not the political community, but there's a reason why the scientific community isn't coming out and saying, you need to get these people off the air. These people don't know what they're saying, right? And the reason is because those people are saying with a relatively unified voice of what we know scientifically. And what you need to not be trusting are the voices that are coming out that scientists like me are saying, well, I haven't seen that data. And I will tell you from the data I have seen that I'm skeptical about that. Or you may even have a mainstream scientist or medical doctor who has seen the data, who has looked at it, and who has come out and said, well, that's just not true. And so I just leave that with you. You can continue to choose to believe and consume whoever you choose to believe and consume. But this is not my political opinion. This is not my personal opinion. This is my professional scientific opinion. Okay. And that's all I can say.
Okay. We're getting several people that are sending statements in on the Q&A. I'm not going to go through them because I can't really ask a question out of a statement. So if you have a question, put it in the form of question, just like Jeopardy. Susan Lambeau says, what about all the adverse reactions that are being reported in the VAERS, Vaccine Adverse Event Reporting System?
Yeah, VAERS. It's the same question Bob and Sharon asked, Ross.
Yeah.
Yeah.
Okay. All right.
So I haven't been to VAERS. VAERS is very not user-friendly. And so I haven't been to VAERS for COVID. I have been to VAERS for other vaccines when I was at RTB and people were periodically asking me about the safety and the dangers of vaccines in general, especially as they're linked falsely to autism. And so I spent a couple of months when I very first started at RTB in VAERS looking at other vaccine adverse reactions, and VAERS is not user friendly. And so it will take you a very long time if you try to go out there and find the data, and then you will have to do extra research and sort of like how to extract that data. And you may or may not have parallel data that allows you to categorize it the way that you want to categorize it, to be able to say, is this correlation real? The answer may be yes, but then you have to ask the next question, even if the answer to the first question is the correlation real, does that mean that the vaccine is causative, right? Like, so there's a difference between causation and correlation.
Right.
And so, yes, so correlation can point to things that need to be looked at more closely, but correlation is not the same thing as causation. And so can the data be out there for a correlation? Yes. Does that mean, does that suggest, or does that actually strongly imply that it is a causative effect? The answer to all of those is no. You have to have more information, and you have to be able to go in and demonstrate certain things physiologically or experimentally, or be able to interrogate the system. And VAERS is not set up to do that, unfortunately. Like, you can't go back and contact trace through VAERS. And VAERS is not, you don't have to be a medical professional to report something to VAERS. So anybody, anywhere in the public can go in and say, I've had this adverse reaction, and I'm associating this adverse reaction to the vaccine I just got. And so that can be totally sort of like unmedically supervised, in the sense of, oh, well, yeah, we actually know that that vaccine can cause those kinds of side effects. So it's a good thing. It was set up to sort of be a watchdog portal against big pharma, and it can serve that function. There are a lot of public policies that could be developed around the VAERS system to make it better. There are a lot of public policies that could be developed around the VAERS system that could be in the public health interest of our population. And there are certainly issues that need to be addressed and that deserve our attention related to those things. But I will tell you, as far as VAERS being the source and one or two doctors' opinions based on going out and compilating VAERS data and then drawing a strong conclusion that the COVID vaccines are not safe and it's unreasonable for an adult healthy individual to be vaccinated, I would just say, I'm sorry, I categorically disagree.
Thank you. Kurt McCorkle asks, what is your view of alternative treatments, especially ivermectin?
I don't embrace alternative treatments when there is a vaccine that is available that is as safe and as effective as these vaccines are. If it was all we had, then I'd say try it. But, you know, hydrochloroquine, I know he didn't ask about hydrochloroquine, but hydrochloroquine is counterindicated for many, many individuals. Hydrochloroquine is a dangerous drug for my sister to take. My sister has lupus. If she were to take hydrochloroquine, she'd probably end up in the hospital and maybe dead. You know, if there are underlying health conditions, certain individuals should not be taking hydrochloroquine. And so to go out there and say hydrochloroquine is great, take it prophylactically, it's going to protect you against COVID. It's like, well, I'm sorry, I think that's irresponsible.
Okay. Susan Lambeau asks a question you've touched on. How effective are most masks as I see being worn? And then I'll add, what can we do to improve the way we wear them? Yeah,
number one, your mask isn't doing any good at all for anybody if it's not covering your nose and your mouth.
Mm-hmm.
Period. I mean, if you think you're doing good because you're walking around with your mask like this, you don't understand the biology of the virus at all. The biology of the virus is that it enters primarily through the nasal route. Its first round of replication is set up in epithelial cells lining the mucosal nasal surface, which is why when enough people became infected, we realized, oh, one of the most initial symptoms isn't a fever, it's a loss of sense of smell and taste. Well, it's because that's where the virus is going first, and that's where the first round of virus replication is taking place, and it's destroying those cells, and it's destroying an individual's ability to smell and taste for a short period of time until those cells grow back. And so if you're wearing your mask around your mouth, well, you know, okay, good. Maybe you won't spew food on somebody if you're chewing and you cough, but you're really not doing anything to help protect the people around you if it's not covering your nose. Again, your mask, unless it's an N95 mask, is not about it primarily protecting you. It is about it primarily protecting the people you're around. Because what that mask is most effective at is to keep those particles we spew when we talk and we breathe from traveling long distances and coming into contact with somebody else. Those masks in particular are not good at all at preventing teeny tiny viral particles on you know, they're still airborne from passing to us. It'll keep some larger particles that will have viruses associated with them if a virus is in the air out, but it can't keep out particles that are small enough to still bear the virus to you. Okay, so the same is true going the other way, but the vast majority of what I project will be caught by the mask. And so anything else that comes out shouldn't be much. It shouldn't travel as far. And if we're masked and socially distanced and we're inside, even where air is circulating, it's like the risk isn't zero, folks. The risk is never zero. The issue is, how can I be 100% safe in a pandemic? Never leave your house. That's how you can be 100% safe in a pandemic. And never have strangers come to your house. That's how you can be 100% safe in a pandemic. How can I mitigate risk when I'm out and about? I can wear a mask and I can socially distance. And I can do that now, even if I'm fully vaccinated, because if Kurt's statistic was what I suspect it was about, the vaccine's only 42% effective against infection with the Delta variant. And if that's true, then even if you're vaccinated, you should have a mask on and you should be socially distancing when you're in public. Meet outside, it's going to be safer than inside. It's always going to be safer to meet outside than it is to meet inside, always. So, you know, that's just the facts. That's just the science.
Doug McComb has a good question. He says, what is your opinion about whether or not the virus has been engineered and by whom? And if you think it was engineered, was it deliberately unleashed?
Yeah. So how much time do we have together? I'm going to answer this question. I just want to know how much time I have to spend on this question, honestly.
Well, technically we've got 3 minutes, but you can take as long as you want because everybody's hanging out. So
okay. Well, this may be the last question then. So, but I think it's an important question. Okay. I just said earlier that there are very few things that I am 100% sure about, right? If you'll recall, I said, I'm certain that God exists. I'm certain that Jesus has saved me, and I'm certain that Jesus is coming back. And these are the things I'm certain of. I am not, and nor can anyone else be 100%, and I'm leading with the worst, folks. I'm leading with the worst here. No one can be 100% sure that this wasn't engineered and that this wasn't intentionally released, okay? So you just can't rule out that theory with 100% certainty. There is no positive evidence. There is no positive evidence that this virus has been genetically engineered. There is no positive evidence that this virus has been intentionally released. Okay, those are the two extremes. Those are the two extremes. One's about what we can know and how certain we can be about it. And the other one is, what does the evidence say? Okay, there is no positive evidence that this virus has been engineered. There is no positive evidence that this virus has been intentionally released. Everything else that I say is going to be part summation, right? I'm going to be supposing some things, but they're going to be rational suppositions, and I'm going to think through things with you aloud, okay? What did we know about coronaviruses prior to 2003? I'm going to throw it out there. This is going to be a little bit of a discussion. What did we know? Please pay attention to the questions, though, to the specifics of the question. What did we know about coronaviruses before 2003? Has anybody been paying attention? Was it too much information?
No, on the webinar, they can't participate. They can't speak.
Well, prior to 2003, we knew that coronaviruses existed, and we knew that they were associated with the common cold. What do we know about coronaviruses before SARS, before COVID, between 2003 and 2019? We knew a lot. We knew a lot more about coronaviruses between 2003 and early 2019 for this reason. The first coronavirus that caused serious human illness and death happened in the first pandemic, which lasted from November of 2002 until July of 2003, okay? Because coronaviruses all of a sudden became an issue for human well-being and welfare, we started studying coronaviruses much more intensely in the scientific community. And what we discovered is that there are other coronaviruses that cause upper respiratory illness that had gone undetected because it's a small number of people that get infected every year, but those people can actually end up hospitalized. What we also learned is that there are breakthrough events from animals that we should never come in contact with, that animals that harbor these viruses in nature should never come in contact with animals that can be an intermediate host that can then pass that virus on to a human population, so that that virus in a human population now might be the type of virus that can cause severe human disease and death, right? So number one, we know that there are things happening in man-made situations that are taking animals from nature and other animals from nature and putting them in close proximity to each other, and then adding the human component. So now you have animal A, which should never come in contact with animal B, which, you know, may, yes or no, should or should not ever come in contact with a human being. But now you're taking all three of those elements and you're putting them together in a market, in a man-made environment. And you're saying, oh, let's see if something bad ever happens. Well, the answer is, yeah, something bad happens frequently, right? So not just SARS in 2003, but MERS, which is another coronavirus that has a case fatality rate of close to 70%. So 7 out of 10 people who get infected with MERS will die. MERS came from camels through bats into the human population. First time we detected it was in 2012. It continues to enter the human population periodically through this year. So there have been MERS infections in the human population every year, not every month, most months, since 2012. So do we suspect that the original SARS outbreak of 2003 was man-made? No. Do we suspect that it was intentionally released? No. Why? Because we identified through surveilling animals in markets in China, where this one also originated. And we found animals that were positive for antibodies to the virus. So it indicated that the animal had been infected by the virus. And we isolated virus from different animals. And the virus that we isolated from some animals was very, very close to the virus that entered the human population. And so we saw a clear chain of transmission from an animal in the wild to an animal that animal came in contact with, that then a human came in contact with that, and we could trace antibodies and we could trace viral strains, and we could say this is a pretty clear-cut pathway of how this particular strain of coronavirus entered the human population. Looks like nature. When we were able to do that, that's a little bit astounding that we were able to do that. We had to get lucky. We had to find the animals that had been in contact with the virus, and we had to be able to find them at the right period of time in order to even isolate virus from them, right? So that animal had to come in contact with the virus. It had to be harboring and making the virus. We had to find the animal, and we had to find the animal in a short window of time when the animal was making the virus. The fact that we were able to do that in the first pandemic of SARS of 2003 is remarkable in one sense. It was kind of like finding a needle in a haystack, but at least the haystack was still there, right? Because when it happened the first time, we didn't know how it had happened, right? And so everybody's still kind of going about their daily activities. And so nobody had disrupted the daily activity scenario. And so we could go in and we could say, hey, what's going on? Where did this come from? Okay, really cool that we could do that the first time. Could we do that this time if, okay, I'm going to give you two scenarios here. If it came from nature, were we able to do that this time? The answer to the question is no, we weren't able to do that this time. Why? Two reasons. The Chinese government didn't tell us what was going on immediately. And number two, by the time the World Health Organization, that's who I mean by us at this point in time, by the time they did tell everybody what was going on, the Chinese system had reacted rapidly, not necessarily, folks, because they were trying to cover something up, although you can speculate that maybe they acted rapidly because they were trying to cover something up. They acted rapidly to shut down any possible continual transmission. How did they do that? They cleared out a market that early indications pointed to might be a source of this particular pandemic outbreak. There is data that would suggest that perhaps that market wasn't the source at all, and that maybe the Chinese system was acting to distract the public attention and point in a direction and remove any possibility of sort of saying, hey, can we identify an animal in this environment that actually is harboring the virus or has antibodies? So that's one uncontrolled situation that we can't go back and repeat. We can't find the answers that we need from that area. The point that needs to be made is the first SARS pandemic and each outbreak of MERS has been a direct transmission from a bat in nature to an intermediate host in nature to a human population, okay? And nature has done that on its own without man's intervention or bioengineering or nefarious behavior at least half a dozen times. The first SARS outbreak and each of those sort of subsequent introductions of MERS, every time a new one of the MERS happens. So can nature do this? Yes. Does nature do this? Yes. Has nature done this more than once? Yes. Okay, so now we talk about the current one, SARS-2. Did nature do it again? Well, it's possible. Nature has done it in the past. Nature certainly can do it again. Nature certainly will do it again. That's guaranteed. Nature will do it again. The question is, did nature do it this time? Okay. What can we look for as scientists? We can look for signs of bioengineering. And so what I will tell you that before CRISPR, I hope you guys know what CRISPR is because I'm not going to take time to describe what CRISPR is. But CRISPR is basically a way that you can go in at a molecular level in the laboratory with the right tools, and you can genetically alter something. And you can genetically alter it pretty much at will, okay? So you can go in and say, I want to change this piece of this virus genome, and I want to put this piece of this other genetic information into that virus genome, and I want to do it right there, so that when this virus, I make more of this virus in the lab, then this virus will have this added protein or this added characteristic that I gave it, right? And CRISPR can allow us to do that with such precision, CRISPR technology, which we've had available to us in the laboratory for this type of activity since 2013. We've had this ability since 2013. So we didn't have this ability when MERS first emerged. We didn't have this ability when the first SARS pandemic emerged, but we had this ability in 2019 that we could go in and we could change the virus genome in such a precise way that we could introduce whatever mutation or change we wanted to introduce. And more importantly, if we were really good and we had sufficient resources, we could go in and make that change and make it so precisely that we would leave no sign that we had done that, right? But it would take a skilled scientist with extreme resources to be able to pull that off. And if they did that, you could almost certainly say that they had a nefarious intent. Okay, so I'm coming back to my initial statement. There's no way I can 100% say this wasn't bioengineered. There's no way I can 100% say this wasn't introduced intentionally. But there's no positive evidence. So that means somebody who just wanted to bioengineer a virus, who wasn't being that nefarious and that careful, like maybe they just wanted to make a virus to study it in the laboratory because they wanted to see what would happen, and maybe the virus got out accidentally. Well, if that's the scenario, then there would almost certainly be a genetic indication that the virus had been manipulated, right? Because they weren't being super careful to erase their genetic tracks. They were just going in to try and introduce a function that they wanted into the virus. And most of the times when you do that type of thing in the laboratory, where you're like, oh, I want to knock this gene out. Oh, I want to knock this gene in. You do it, and you do it in a way where you're going to get the function that you want, and you don't care about the genetic footprint that you've manipulated the virus. You just care that the virus is going to do what you want the virus to do. You're not going to take extra effort to go in and erase a genetic footprint because you don't care if the genetic footprint's there. Sometimes you even intentionally introduce a very strong genetic footprint into what you're doing so that you can track it in your laboratory experiments afterwards. And so these are the types of things that most scientists do when they're doing these types of experiments. You know, it's like, will this change make this virus behave this way? Will this change make this virus behave that way? They leave signs of their genetic manipulation. There are no signs of genetic manipulation in this viral genome. How can I say that? How can I be certain? Because I've done the studies. I did those studies with 3 other scientists that someone contacted me about last October. And I took, actually it was before last October because it was before I started with the PTO. So it must've been like last June or July, a year ago. And we spent 5 to 6 weeks actually looking at the sequences of the different viruses that were found that were reported in humans, that were reported from the laboratory strains, what was available. We looked for genetic manipulation. Okay, I'm just telling you I did it so that when I now say, and oh, by the way, there were 2 different groups of scientists. One group who I know 2 of the scientists on the paper from my work at Penn as a graduate student, and another one who I recognize their names, but I don't know the people personally. Anyway, there are 2 published works out there that says the exact same thing. There is no genetic evidence of human manipulation of these viral strains or sequences. 0 positive evidence. 0 positive evidence. All right. Last thing I'm going to say about this is, having worked with biosafety level 3+ viruses. Okay, so biosafety level is how dangerous is this virus? What happens if this virus gets out into the public? How hard are we going to work to contain it so that it doesn't get out into the public? Most viruses, most influenza work, biosafety level 2. SARS, the original virus that I worked on at the NIH, biosafety level 3. And so biosafety level 3 means the only way you get into that laboratory is if you have an ID that gets you past lots of locked doors. You go through anti-room, usually typically a second type of anti-room, and then usually into a containment laboratory. Those containment laboratories are HEPA filtered laboratories. They go through really strong filtration so that there's no way anything that's in that laboratory would ever be released into external air. In order to go into the first anti-room, you have to be basically covered, physically covered with something that's protecting your underlying garments. By the time you enter the second anti-room, you're putting in some type of independent HEPA filtration to a hood that you're connected to that's usually battery operated so that the air that you're breathing in your little suit is HEPA filtered. Now, this is not like what you've seen in Contact, right? Where those are biosafety level containment 4 laboratories. That's even more containment. But this is you have to breathe your own air. You can't let anything in the laboratory come in contact with you, and everything that's in the laboratory is going to stay in the laboratory, and there's no way it's going to get out. So when we egress, when we're ready to leave that laboratory, we basically return our HEPA filtration, and then we step into the last anti-room, at which point we completely take off all of our outer layer. It goes into a biohazard bag. That biohazard bag goes directly into an autoclave system. It gets high pressure, high temperature, and only comes out the other side after you've confirmed that that decontamination process got as hot and as wet for as long at the pressure it needed to be. You take it out, and then it can go into waste garbage. But you as an individual, you've stripped down everything you had on the outside is now in that biohazard bag, and you egress the facility. That's biocontainment level 3. Biocontainment level 3 plus is everything I just mentioned, except after you take the outer garment off, you're actually naked at this point because you had to take all your personal clothes off before you put that outer garment on. And the only way you get out of the laboratory after you take the outer garment off and you're naked is if you have to shower. And so you shower out, and then you go back into a locker room that you left previously naked, and you reclothe, and then you leave the biocontainment facility. That's biocontainment level 3 plus, okay? So why did I spend so much time describing that to you? Because people who research viruses like SARS, we know the risk. We know the risk to ourselves, and we know the risk to society. And so we put containment facilities and procedures in place. And we don't put them in place because we want to save our little scientific butts. We put them in place because we want to save our little scientific lives, right? So right, there is deep personal interest in following the procedures when you're working in a containment facility. Everyone who works in the containment facility in China, including the person who you may have heard of, the female scientist who has collaborated with the North Carolinian scientist on creating coronaviruses to replicate human disease. That woman is known personally by my boss at the NIH, who I worked with personally, who is now running the World Health Organization for Australia and is influenza pandemic researcher #1 in the country of Australia from the WHO. And so my boss's name is Kanta. You could look that up. It's not that hard. Kanta knows the scientist in the Wuhan Virology Institute. She knows and vouches professionally for that woman's professional behavior, right? That woman works with this researcher at North Carolina. He's a guy who I've known since graduate school. His name's Ralph Barrick. So I know these scientists, or at least I'm one person removed from the scientists in Wuhan. And so I can tell you that we act in self-interest, right? And even if I were a communist Chinese individual who had different values than an American Christian or an American capitalist or an American Christian capitalist, even if my values were different, my sense of personal danger and need for personal protection in working with these types of viruses would still be grossly intact. And so now the question becomes, which is more likely? If we can say, okay, I cannot answer the question about whether or not a nefarious individual bioengineered this, intentionally erasing any genetic track of manipulation. I cannot rule that out. It's still out there. You can still place your camp and your flag in that camp if you choose to. I can't rule it out. I can say we've seen nature do this, and nature can do it, and nature will do it again. Did nature do it this time? My suspicion is yes, but my confidence level is not 100%. Is it more likely that nature did it or that it was a laboratory accident? Because that's really the next question you've got to ask. And I went through all of that. This is what we do for containment. And this is how much we take it seriously if we're actually working with these viruses, regardless of what our political or faith values are, just the personal preservation value. Those individuals in the Wuhan Institute, even if they weren't doing everything 100% correct, they're still going to be doing, hopefully, the minimal in trying to protect themselves, right? And so is it more likely that it was a careless researcher at Wuhan who's at least attempting to take these types of biocontainment precautions for their own well-being? Is it more likely that that happened? Or is it more likely that we just didn't find the needle in the haystack because the haystack was burned too quickly, and that some animal that didn't belong next to another animal in nature were put next to each other alongside human contact, and perhaps asymptomatically, right? And that is not an unreasonable expectation, considering 50% of infections are asymptomatically spread from somebody in one of these markets to somebody else. And oh, by the way, if it happens to be the largest market in that particular area, are people from the laboratory going to be shopping in that market? Or are people in the laboratory going to be coming in contact with people from their family who shop in that market? It's like, right? So when you go into a population where the virus is already emerging into the human population and you try to find the index patient, the first infection, it's like, and you only have, you have some percentage of probability that you're not ever going to be able to find the index person for this particular outbreak because it's only 50% symptomatic, right? You may never find the index case because I could be infected. I could be patient 0. I could not have symptoms. I could go to the market and I could spread it to 20 people. 10 of them won't have symptoms. 10 of them will. 10 people who don't have symptoms go home to their husband or their son or their daughter who works at Wuhan, right? And now people at Wuhan are in the chain of infection. And where do we first detect the first symptomatic case, right? The first symptomatic case is the only one that we can now say, hey, this person's sick. What do they have? Oh, gee, I don't know. Oh, wait, 10 more people are sick. What do they have? Oh my gosh, it's a new coronavirus, right? Okay, where did it come from? Because of the percent of symptomatic cases, and because of the scenario I just laid out, those people in the markets dealing with the animals, no personal protective equipment, no equipment to try and keep a virus that they don't even know is there from not being transmitted. So again, I can't completely divorce myself from my training, from my bias, from my perspective, but I look at the situation and I say, is it likely to have been a biological accident in a laboratory? I don't think so. I think it's much more likely that it happened in nature. Can I rule out that it was a biological accident? No. Can I rule out that it was biologically engineered and nefariously released? No. But my confidence is that it can still happen in nature. And I will leave you with this question. I'll leave you with this question and this comment. Regardless of where it came from, this is the comment first. Regardless of where it came from, there are things that need to change. And there are policy things that need to change. And there are responsibilities in the Chinese system for the way that they interact with the rest of the world. And there needs to be greater transparency. And I just don't know how much of that we'll ever be able to achieve with a communist government. But, and this again is just part of the commentary, but one of the ways that we can have a foothold to begin to address those types of policy choices and changes is not just from an American political pressure perspective, but is actually through an organization like the World Health Organization. Because these people who work for the World Health Organization are going in with the intent of helping countries monitor and report for the safety of not just that country, but for the safety of the world. And so we really need to be aware that despite the shortcomings of all organizations, that some organizations have at the heart of what their mission is something that's vitally important for us to be able to protect ourselves as a global community. So there's always room for improvement, but if you shut that door, you've shut a major pipeline of communication that could be for our public health and for the global public health. And so that's my comment. My question is, once we've placed blame wherever blame belongs, and there is blame to be placed, what is it that we hope for? What do we hope to accomplish by being able to blame responsible parties for the element that they're responsible for? What do we hope to accomplish once we've placed blame? Because the reality that we're living in, now I'm back to commentary, the reality we're living in is we're facing a pandemic and we have to control the pandemic we're facing. So yes, is it important to go back and ask, where did this come from? What can we do to maybe protect ourselves in the future? What can we do to hold responsible parties responsible, and therefore hopefully ask them to change their behavior moving forward so that we don't face this type of thing again, or if it happens again, we can face it more quickly and more responsibly together again. But the reality we're left in is we have a situation that we can address, that we need to address. And the longer we continue to make this more about politics and less about public health, the longer we're playing with a virus that's going to continue to change. And the next strain may be as contagious or more contagious than the Delta variant. And the current vaccine may be less efficacious than 42%. And so then where are we? Well, we're back to a third wave of a pandemic. And those of us who have been vaccinated are now having to wait for Big Pharma to develop another vaccine that will be more effective so that we can be vaccinated again. And we could actually end up in this cycle for quite a long time if we don't ever reach herd immunity quickly against whatever the prevalent variants are. And whatever you've heard in the media, I have the benefit of sort of decades of thinking about these issues. And when I hear something in the media, I can just be like, oh, that person's just full of it. I can't believe they just said that. And I realize that the people around me don't have that same filter. But the thing that upsets me a little bit, actually more than a little bit, is when people who ought to know better say things that they ought not to be saying. So I will say, for instance, I worked with Tony Fauci. I was upfront about that in the beginning. I actually think Tony Fauci is very good at his job, but he is a human being. I am not going to tell you that Tony Fauci's motives are always pure. I don't know the man's heart. I don't know the man's thinking, but I have heard him say on really only 2 occasions, maybe three occasions. I've heard him say something that I'm like, oh, Tony, why did you just say that? Why did you just say that way? Because what most people heard when you just said that was this, and you needed to say 15 minutes more of something else behind that without leaving that person with the wrong impression. And one of the things he said a few months ago was that herd immunity will probably be achieved when we hit 70%. And I got to tell you, I just went ballistic in my living room when he said that. And I was listening a couple of weeks later, I was listening to the This Week in Virology podcast, and it was kind of like they had the same reaction. And I was just like, yeah, it was so irresponsible to say that, because there's no way anybody like a virologist should ever think that we're going to get to herd immunity with anything less than 85%. And so I just heard yesterday somebody come out and say, oh, well, it looks like we're going to have to be around 80 or 85% before we hit herd immunity. And I'm just thinking to myself, why are you just now saying, oh, we're just now saying? It's like, that is, every virologist I've known since day one of this pandemic has said, we're going to have to be 85% herd immunity before we can get past this pandemic. And so it's like, where do you go for your resources? I realize you guys don't necessarily have the proper resources, but all you can do is be patient. You know, it's like, I can't control what other people are saying in the media. I can't control what's getting repeated sometimes. And sometimes I'll say to my friends, sometimes I'll post on social media, and I don't know if I did or not at that point, but if you go back and look for anything that I've posted as far as herd immunity, I've never quoted anything less than 85%. So yeah. And why am I belaboring that? Because it can't just be 50%. It can't be 55%. We're not out of this pandemic. We're not anywhere close to out of this pandemic. We won't ever be close to out of this pandemic unless one of 2 things happens. We reach 85% herd immunity to the circulating strain, and we do that before our vaccines are inadequate, or something happens to the virus that causes the virus itself to lose infectivity. And we know it's not going to be a seasonality, and we know it's not going to be containment, because we can't contact trace against a virus that is only 50% symptomatic. We can't contact trace effectively against a virus that's only 50% symptomatic. So we could do both of those things in the first SARS outbreak. We could trace, we could contain, and yeah, we could isolate and quarantine much more effectively. And there's no indication that this is going to be going away in the warmer summer months. It may reduce transmission in the warmer summer months, but it will not go away in the warmer summer months. We have plenty of evidence that it's not going to go away in the warmer summer months. So sorry, guys, that was a really long response with a lot more information than the question that was asked about bioengineered viruses and nefarious intent. But thanks for letting me share it all.
AJ, thank you for being so generous with your time. We lost exactly 0 people.
Okay.
In the time that you did that. So the interest is there. This has been really, really wonderful.
Yep.
Thank you so much. And I know we know you're really busy, and this was terrific. We all needed to hear this.
Yeah. And, you know, I don't know how much longer I'll be at the PTO. The reality is that it's way too much work. And a lot of the things that I would rather be involved in are suffering because I spend way too much time on my PTO job. So if you guys think of it, if God brings me to heart or mind, pray for me. I'm trying to pursue some clinical pastoral education in the near future. And I think one day I'd eventually like to pursue chaplaincy. So sort of chaplaincy in the public arena, maybe hospice, maybe elsewhere. But that's where my heart is. And if I pursue that, maybe I'll have more time for things like this and or teaching a little bit on the side. So.
Well, we'd love to have you back.
Yeah.
That's for sure.
Yeah, I don't
awesome.
know if everybody would like to have me back, so maybe we need to have an in-house conversation about that. Since they seem to think I'm only like reporting the sort of party line of the mainstream media. So Anyway.
Well, I sure enjoyed your book that you did with Mark and
Mhm.
Fuzz, Sue Dykes. That was a really, really good book, the 25 questions.
Thanks so much, Ross. That was a labor of love, a book that really took a toll on me and my health. So, yeah.
Well, it's a marvelous product, and it's going to be out there forever. So,
well, thanks be to God. Yeah, yeah. May it outlive me. In a positive sense.
Well, AJ, would you close us with a prayer?
Sure, I'd love to. Thank you. God, thank you so much for the faithful people that you bring week after week to this paradox class and to fellowship and to seeking truth together. Lord, thank you for working in each one of their lives. Thank you for drawing them to yourself. And thank you, Lord, that each of us, no matter where our views are in regard to the vaccines or the virus or health, that each of us ultimately rests in and trusts in you, and that these trials, these momentary afflictions, even when they're pandemic sized, that these things are things that are brought into our lives in which you long for your people to be showing each other love in the name of the Lord Jesus Christ, for the sake of testifying to the world that you are who you said you are. God, thank you that these things are passing. Thank you that as we pass through these trials with your Spirit, that we are being formed into the likeness of Christ. Please, Lord, keep each of us mindful of your love for us. Keep each of us mindful of our need for you and our need for one another. And keep each one of us humble about what we can know and what we think we do know. And always give us a willingness to listen to one another, a willingness to consider things we haven't considered before. And Lord, please lead us into truth. More than truth, perhaps, not more than truth, alongside truth, Lord, would you please also lead us into being ministers of mercy to a world that's broken in such a way that they might come to know your love for them. We ask these things in Jesus' name. Amen.
Amen. Okay, it's great to see you. Thank you again.
Really good to see you, Ross. God bless you. God bless everybody there. Tell Colleen I said hi and all the other people I know. So,
all right. Thank you.
Ta-ta for now.
Bye, everyone.